A very good afternoon to all of you. So welcome to this second live session for the course Computational Fluid Dynamics for Incompressible Fluid Flows. So if you have any questions who are in YouTube, you can post there, and also who are online in Teams, they can join here and interact directly with me. So Sapnil, do you have any question? Sapnil, you unmute yourself.
Hello.
Yeah, Sapnil. Good afternoon.
Good afternoon, sir. Sir, actually, a few days back, sir, I just mailed on your email ID, sir. So regarding, sir, I had a query about the coefficients, about the equations. I think so. It was in lecture 3 or 4. It was. So I was unable to find the coefficients, sir. So I have kept that whole thing in the email, sir. So is it possible?
In the assignment?
No, sir. In the lecture it was, sir. So particular lecture, sir. Wait, sir. I will also open my draft.
So can you please send me in my institute email address?
Sir, I have already shared on your institute email ID, sir. Sir, just a minute. I will tell you that which email ID it was. Just a minute, sir.
Okay, so if it is specific to some lecture, I will check and I will let you know. Okay.
Sir, the mail ID was amaresh@iitg.ac.in. Is it fine, sir?
Yes.
Okay, sir.
So I have to check whether it has gone to the junk mail or not. Sometimes it goes to junk mail. Okay, you please forward it again, because periodically from junk mail the mails are deleted. Okay.
Yes, sir.
So you forward it. I will just reply.
Okay, sir. I will once again forward it to you. No issues,
okay,
sir. Thank you, sir.
You just forward. Okay.
Yeah,
and there are some questions that I want to address. One is that how we can do CFD analysis on heat sink and how to write differential equation for it. So so it is asked in the form. So say when you are solving like problem heat sink, so if it is fluid flow is happening, then obviously you have Navier-Stokes equations and energy equations. And in the energy equation now, if heat sink is having some means heat flux, okay, so that you can give as the boundary conditions. Okay. So and also if you have some heat generation, so that in the equation itself, the energy equation, one term is Q triple prime. So Q triple prime may be positive or negative depending on means it is heat sink, so it will be negative. So that way you just model it. So I do not know what problem you are solving. So if you know the boundary heat flux, then you can apply the boundary condition. Otherwise you solve the energy equation with the heat generation term. The next question is in FTCS and BTCS, the expression in left side of the time derivative as explained in your lecture is same, even though one is forward time and other is backward time. So sometimes the student get confused. So this I will clarify now. So I'll share my PPT and then I'll just discretize it. Then you'll understand. So it was the question was given by Afroj Alam. Okay, so the we have taken as 1D unsteady heat conduction equation. So del T by del T, okay, del T by del T is equal to alpha del 2T by del X square. So one dimensional unsteady heat conduction. Now we have used FTCS. So we have used T I n plus 1 minus Okay, so now FTC is forward times central in space. So this way we have discretized. Okay, TIN divided by delta T is equal to alpha TI plus 1 minus 2TI plus TI minus 1 divided by delta X square. So if you remember, we are going from n to n plus 1. Okay, so this is the delta T time step, and specially you can see that it is I plus 1, I minus 1, and this is the delta X, and this is delta X. Okay, so now when we are using FTCS, so we are putting in here. Okay, so you can see that all are known term except TIN plus 1. Okay, so that is the FTCS. So this is one explicit scheme. So only one unknown is there. But when we are using BTCS, now the question is that why we are not taking in other way, because this term it is written in similar way, right? So backward always we see that in the backward point. So now if you see that if you take backward point, that means you are telling that I want to take n and here n minus 1. Okay, then n will become current time. Okay, but always we are telling that n plus 1 is your present or current time, level, and this is your previous time level. Okay, so now if you are telling that n and n minus 1, then n will become the present time. Okay, so that's why we are taking TIN plus 1 as a present time level and TIN, and all these at n plus 1 time level. Okay, so the difference now you can see that here all we are taking at n time level, because n plus 1 we are keeping same in the sense that n plus 1 always were unknown term. So that is your present or current time level. Okay, so where we want to find the means at which time level we want to find the value of temperature. Okay, so obviously this we are keeping same in the FTCS, BTCS, but that we are adjusting in the special discretization this time level. Okay, so now when we are using FTCS, so obviously forward in time, so because all are n and n plus 1 is one unknown, and when we are doing backward, now you can see that n with respect to n plus 1, so n is the backward point. Okay, n time level, so n plus 1 n, because all we are taking at n plus 1 time level. So this is your, you can see more than one unknown is there, and it is implicit scheme. Okay, so that way just we have adjusted this left hand side, keeping n+1 as it is a present or current time level, and accordingly we have changed the time level in the right hand side n or n+1 for backward time level case. So I hope that you have understood. It is for just representation of unknown at n+1 time level. Okay, so that's why it is backward time central space. Okay, so Sapnil, I will just check the this lecture. Now it is feasible. It's not feasible. Okay. I can write. You can write it. Nothing is there. It's there. Okay, so you can see now what we are talking FTCS and BTCS. So in the FTCS, we are taking n+1 is the current time level and n is previous time level and forward time. So all other term you can see in the right hand side, we are taking at n time level. But when we are using BTCS means backward time, so all we are taking at n+1, and when we are doing the time discretization, we are going in backward time, so 1 is n time level. So with respect to this n+1, n is the backward time, and you can see that all these we are taken at n+1 time level. So that way it is BTCS. Okay, so for easy representation and having n+1 time level as current time level, we have discretized this way. Okay, so I hope that I have explained and clarified your doubt, and this is the implicit scheme. For any other questions you have? Okay, Swapnil, I got your message. So obviously, I have already discussed in the lectures, taking different example problems that how to find the coefficients. So I will give some reference material or book so that you can read those things and clarify your doubts. Okay. Niraj, do you have any question?
No, sir.
So one question is that reference book on CFD for undergraduate and diploma level program. Obviously, say I told that there is no textbook for CFD, but there are many references, reference book. So if you see my introductory lectures, so there I have mentioned several books which you may actually download from the net. So you can refer from the specific topic like Anderson and Fletcher, Computational Fluid Dynamics. This book is good. You can actually refer that book. But and also some Indian books are there. So those things I have mentioned there. So Indian authors' books. So that also you can refer and study. But whatever topics I have covered in one book, you will not get. Okay. So from different CFD books, I have just referred and prepared the lecture notes. Okay. Okay, so now let me solve one or two problems. If you don't have any questions, so I'll just solve some problems now. Is it visible? PPT is visible?
Yes, sir, it is visible.
Okay, thank you. So let us say that you have one heat conduction. So you are asked that there is one-sided discretization you have done. So these are the temperatures given in the heat conduction. This is your T1, T2, and T3. So T1 is 30 degrees centigrade. Sorry, T2 is 30 degrees centigrade. T3 is 60 degrees centigrade. And this is delta X, uniform grid size. And delta X is given as 0.05. Okay. So now you are asked to find the value of T1. Okay. In terms of using the values of T2 and T3. Okay. Using the values of T2 and T3, if this left boundary is adiabatic. Okay. So this is adiabatic. So what do you mean by adiabatic? Adiabatic condition is that there will be no heat loss from that boundary. That means heat flux is zero. So heat flux is zero. That means you have Q double prime is zero. So that means if this is the x direction, so obviously you can see that del T K del T by del X, okay, will be zero. So obviously you can see that del T by del X will be zero for adiabatic condition. So now as you have to use 3 points formula T1, T2, T3. So one-sided forward difference you have to use, which is second order accurate. Okay, so using the formula you have to remember, or you can also derive it. So for T2 minus T3 by 2 delta X is equal to 0. So as you are asked to use the values of T2, T3, you cannot use only the 2 points T1 and T2 using forward difference. You cannot use because you are asked to use the values of T2 and T3. And obviously it is a second order accurate. So you have to use this formula, and now you can find the value of T1. So minus 3 T1 plus 4. T2 is 30 degrees centigrade and minus T3 is 60 is equal to 0. So 3 T1 is 60 and T1 is 20 degree centigrade. Okay. So similarly, for similar problem, if you consider right boundary as convective boundary condition. Okay, convective boundary condition where T infinity is given 300 degrees centigrade, H is given heat transfer coefficient 250 watt per meter square Kelvin, and thermal conductivity of the solid is given 5 watt per meter Kelvin, and again you have to use 3 points. So this is your T100, this is your T99, and this is your T200. 98, and values of temperature at T98 is given as 750 degrees centigrade, and T99 is given as 600 degrees centigrade. Now, and delta X is given as 0.12. So now you are asked to find the value of T100, okay, using T98 and T99 values, okay. But you remember here you have convective boundary condition. So earlier case it was adiabatic, so del T by del X was 0. Now here you have to use the convective boundary condition. So what is convective boundary condition? So this is mixed or Robin type boundary condition, right? So convective boundary condition is minus k del T by del X, okay, which is heat is conducted, okay, in the x direction should be heat convected. So H into T minus T infinity. So that is the formula. So now minus k del T by del X. Now you have to discretize using backward difference. Okay, so backward points, two backward points you have to take. So total 3 points. So this is your second order accurate. So you can write this way, divided by 2 delta X is equal to, okay, H into, so T 100 minus T infinity. So from here you can write T 100 as 4T99 minus T98 plus twice H delta X by K T infinity divided by 3 plus twice H delta X by K. So now you put all the values. So 4 into 600 minus 750 T98 and plus twice H is 250, delta X is 0.12 divided by K is 5 into T infinity. T infinity is 300 divided by 3 plus done. Okay, so if you put all these values, then you will get 50 degree centigrade.
स्क्रीन को मैक्सिमाइज कर लीजिए
पिन कर देता हूँ सर सच Okay, so this is the temperature at this point 300. Okay, using this one-sided backward difference, which is second order accurate. Okay, so this is the boundary conditions, adiabatic boundary condition we have discussed, and the convective boundary condition. Approach. We answered your question. Have you heard that?
I read one question on with the web portal.
Your voice is not clear. Can you please?
Sir, can you hear me?
Yes. Yes. Yes.
Hello?
Yes.
Sir, actually, I asked a question regarding the backward.
Yes. I
backward.
discussed. I think you joined late. Okay.
Yeah.
Again, I will describe. Okay.
Okay.
Hmm.
Due to technical sir, fault, I.
Okay. No problem. You see this one. Okay.
Yeah.
So you can see that in FTCS, if we take this 1D unsteady heat conduction equation, then we have taken FTCS means forward in time, central in space. So central in space, okay, Ti plus 1 minus 2Ti plus Ti minus 1 divided by delta x square. And we are going from n to n plus 1, where n plus 1 is the current time level and n is the previous time level and delta t is the time step. And similarly, delta x the step size in the grid. So now we can see that when we're talking about forward time, that means from with respect to n, where n plus 1 is the current time and n plus 1 is the unknown. So that way we have used Tin plus 1 minus Tin by delta t for the temporal derivative, and in the spatial derivative all these terms we have taken at nth time level because forward time we are taking. So that means with respect to n, you can see that n plus 1 is the forward time, and that way we have written. When now you have confusion that in BTCS why you have not gone in the backward time, like which way we go for spatial. So we have gone that way, but you can see that what way we have done first. Then now what we did, now if it is a backward time, then from n to n minus 1 you have to go. Then approach. So
Yes, sir.
can you hear me? So
Yes,
now what
yes,
we are
sir.
doing, say if we tell the backward time, then backward time we have to go to n minus 1. But n minus 1, then n will become the current or present time level because one unknown should be there.
Yes,
So
sir.
instead of that, I am shifting one level this way. N plus 1 is current time level. So with respect to that, now n is the backward time. And you can see that in the spatial time discretization, all we have taken at n plus 1. So all these n plus 1 with respect to this time level, n is the backward time. So that way, this is your backward time discretization, and n plus 1 is unknown. Okay, here also n plus 1 is unknown, but in all this time level. So this is one way, it is forward time discretization, and here backward time we are taking in keeping these all these at n plus 1 time level. So that way it is backward time. So there is no confusion when we are doing this. Otherwise, you have to take Tin minus Tin plus n minus 1, and all these you have to take nn. So now you n will become your present or current time level. So have you understood approach?
Means n plus 1 is not a current time, it is a backward time.
Yes, so that this way it is backward time.
N is the current time.
Huh?
N plus 1 is the backward time or current time, sir?
No, no. Now what we are doing, say in a forward time, we have gone from n to n plus 1.
Yes.
In backward
Yes,
time,
sir.
we are going n plus 1 to n. So you can see all these are
Okay.
n plus 1. Then we have gone n plus 1 to n. So that way we have gone. And here our reference point was n, and with respect to n plus 1 is the forward time. Then that way we have taken, and all these are nth time level. So if you go this way, then you have to go to n minus 1. You want this, then
Yes,
you have
sir.
to write this one. Alpha, so ti plus
Yes, sir.
1 n minus 2 ti n plus ti minus 1 n divided by delta x squared. This is also correct. But what will become?
Yes, sir.
N will be unknown then.
Yeah. Yes, sir.
Okay, so instead of that, now you make one level higher so that n plus 1 will become unknown. And now this is n, and this n will become n plus 1. So that way it is backward time. Have you understood now?
Yes, sir. Yes.
You can use this
Yes,
one
sir.
also, but now n is the unknown. But instead of that, we are always telling that n plus 1 will keep as present or current time level, and n is known time level. So that way we have discretized this equation. I think now you have understood this one, right?
Yes, sir. Yes, sir. Thank you very much.
Yes. Thank you. Okay, so let me see if some other questions are there or not. Okay, so one question is there regarding the assignment 5. Can you please post it in the discussion forum, because I don't have the ready-made this assignment problem with me, so I cannot discuss it. You could have posted it earlier, then I could have answered now. But you please post it in the discussion forum so that I can answer. So this is posted by Sital Smita Samal. Okay, so you please post it in the discussion forum, then we'll answer. Okay, Sital Smita, you unmute yourself. Sital Smita, you can. Hello.
Yes, sir. So, sir, query. Sir, you have explained many stability criteria, conditionally stable. But sir, there are most. It is very difficult to remember the which scheme will be which stable or not stable. There is any criteria to find out the stability?
No, you have
Any
to
method
say you say if you are asked to find, then you have to go as per this yeah. But most of the time, say forward time means which are explicit scheme. Explicit scheme are mostly you can see that conditionally stable or unconditionally stable. Sometime, and for backward time, which is an implicit scheme, so mostly you will find that these are unconditionally stable, but these are not general statement. There are means exceptions, but that unless you do the Bandhan stability analysis, you cannot tell, so you cannot remember. But for few equations which are very well known, like say 1D wave equation or 2D wave equation, or your this 1D unsteady heat conduction equation. So these are common equations. So you should know what is the stability criteria for FTCS and BTCS schemes. Okay, which are common equations we encounter.
Hello, sir.
Yes.
Hello,
Sital.
sir. This is Sital. Sir,
Yes.
I have
So,
some doubt.
Yes, regarding the assignment, you post it
Yes,
in
sir.
the
Yes, sir.
discussion forum so that we'll answer.
Not
Now
the
you please
particular
discuss.
question. Just hello.
Yes, please.
Yeah. So there is some type of question like the left arm temperature is given and right arm temperature is also given, and also initial condition is given. The initially the temperature is at rest, that means temperature is 0. Then what to take the value of U at 0 time level and also at 0 space level. Should you use the
I didn't
initial
get you.
condition?
Say you are telling that.
The left if a rod there is a rod and the left arm is at temperature 100 degrees Celsius and the right arm is at 50 degrees Celsius.
1 minute, 1 minute. You please hold on. 1 minute. So what you are telling? Say there is a rod. Can you see me?
Yes, sir. Yes, sir.
My screen.
Yes, sir.
So now left one you are telling.
The left arm is at 100 degrees Celsius.
Okay.
And the right is at 50 degrees Celsius.
Okay.
And the rod and the initial temperature of the rod is 0 degree.
Okay.
Then so for solving this type of question, to find the value of the temperature at first time level, second time level, we need the value at that is 0 time level at 0 space, that means U00. What to take the value, that means should we use the boundary condition?
Say T00 never will change, right? Because T is the boundary condition, right? At x equal to 0. Okay. If this is x, so if x is equal to 0, then always temperature will be a boundary value, 100 degrees centigrade. It will not change with time. Only the interior points if you have, okay. So if it is, say, let us say T1, this is T2, and say, let us say this is T100, this is T99, then this value will change with time because initial condition is 0 degrees centigrade and you are solving this equation del T by del T is equal to alpha del 2T by del X square. But as T tends to infinity, it will become steady, okay? And you will have linear variation from 100 degrees centigrade to 50 degrees centigrade. So if it is X, so this is your temperature, so this is your 100 degrees centigrade and this is your 50 degrees centigrade. Okay, so this is the linear variation you will get at steady state, okay, at T tends to infinity. But initial time, it will evolve from 0 to some value. So that time interior points you need to evaluate solving this equation. Okay. But at the boundary, there will be no change in the value because boundary condition is given. So it is 100 degrees centigrade only.
Yes, a boundary condition is given, but at the left end point, that means at the 0 node and at the last node, there may be boundary condition can be applied also. Initial condition is also applied. Because
no, initial condition is for the interior points.
Okay, sir.
The initial condition we put on. Can you hear me?
Yes, sir. Yes, sir. Now.
What I'm telling that initial condition is for interior points because boundary condition is boundary condition. So if you have any domain like this, so this is your boundary and this is your domain, interior domain. Okay. So boundary condition will be applied at the boundary only, and initial condition will be applied at the interior points. Okay. So when you have 100 degrees centigrade, that means boundary condition is 100 only always.
Okay, sir. Thank you, sir.
Okay. Okay. Thank you. Okay, so thank you. If you have any further questions, you please post in the discussion forum. We'll answer, and again we'll meet in the third live sessions. And if you have any doubts, you please post it early when the form is shared, so it will be easier for me to see if it is related to some lecture or it is related to some assignment. Then I can come prepared. Okay, so thank you very much. So again, we'll meet in the third live session. Thank you.
Thank you, sir.